Hi, everybody. So today we're going to do another lesson that is a review lesson. Basically, we are going to review our rational number operations. So we're going to just remind ourselves about those positive and negatives, basically. Again, we're working with the essential question of why is it helpful to write numbers in different ways? We're getting ready to head into using some exponents. So we want to get our positive and negatives all back up into the front of our brain. So today's objective is to review rational number operations. To all of you that find this very easy today, that's fine. Just take a nice deep breath. But let's just make sure we're all on the same page. Now, I want to start, first of all, talking about multiplication and division. Multiplication and division of positive and negative numbers are actually the easier operations. So we're going to start with the easier. There are really four ways to write multiplication in math. We can use the X. We can use a dot. When you have a number next to a set of parentheses, there's an implied dot. That's multiplication. And this star-looking thing is often what you will see on a calculator. The 4 times x using the x is really something we don't do in higher math because that starts to look like a variable. So really, you're going to see the dot, you're going to see the parentheses, and on a calculator, you'll see the star. Now let's take a second just to talk about what happens with division. There are 3 ways to write division. There's the traditional elementary sign with the line and 2 dots. There is making it look like a ratio or a fraction where you've got the numerator and the denominator, the top number divided by the bottom number. And then also in a calculator, or sometimes it's easier to type it this way, the 20 divided by 5. Remember that the 20 is the leader into the calculator when you do division. Now, we're not going to be using a calculator today. So I'm going to ask you to make sure that your calculator is put away. We need to make sure that you have a comfort level of doing these operations without the calculator. For those of you that your multiplication and division might need just a little bit of assistance, a multiplication chart is what you would use for just today. So the big idea when you're multiplying or dividing 2 numbers is that when the 2 numbers have the same sign, your answer will always be positive. And when the 2 numbers you're either multiplying or dividing have different signs, your answer is always negative. So if you look down here, if you take a positive times a positive, notice they're both the same sign, you get a positive. If you take a negative times a negative, the answer will be positive because they have the same sign. Same thing with division. Now, if your first number is positive and the second number is negative, because they have different signs, your product, your answer will be negative when you multiply. And over here, it will also be negative when you divide. Now, I have a silly little story. If you are good with this idea, that's great. But I have a little story that I use sometimes to kind of keep this in mind. My story only works. Did everybody hear the word only? It only works for multiplication and division. So here's the story. We're basically going to have the first number. If it's positive, that's something that happens to somebody. So something good would be positive, like winning the lottery. That first number, if it's negative, would be something bad happening to someone, like being thrown in jail. The second number is going to be the type of person that thing happens to. So a positive would be a good person and a negative would be a bad person. We don't really talk about people being bad, but just for my story, go with it, okay? And then you're going to have a result. Your answer. If it's positive, that would be a good thing. And if it's negative, that would be a bad thing. So here is my story. So if you have a positive times a positive, the first one being something that happens to you, if you won the lottery, if winning the lottery happens to a good person, right? Positive, positive, that's a good thing. That's fair. Now the first thing, let's say the first number is negative. That would be a bad thing, like being thrown in jail, and that happening to a bad person. So being thrown in jail for a bad person would be a good thing. That's fair. Now let's talk about one of each. Winning the lottery, a positive thing happening to a bad person. If winning the lottery happens to a bad person, wait a minute, it's not fair. That would be a negative. And if a bad thing, like being thrown in jail, happens to a good person, a bad thing happening to a good person, wait a minute, that's not fair. That would be a bad thing. So there's this little story to kind of remember, but I need to caution you again, it is only for multiplying and dividing. So here are some examples. And what I'd like you to do is pause the video, or the Ed Puzzle will do it for you, and write the answers to 1, 2, should be no problem, 3, think a little bit, and see what you think about 4. Pause the video, and when you're ready to go, come back and let's see how you did. Okay, so the first one, a positive times a negative, different signs, that would be a negative, or if a good thing happens to a bad person, that's a bad thing. So you're going to have a negative answer, and that negative answer will be 6 times 3, which is 18, negative 18. When a bad thing multiplying, now remember, these are both multiplying. You've got the parentheses, you got the dot, right? So when a bad thing happens to a bad person, ooh, well, that's fair. That would be a good thing. It would be positive. They're both the same sign. It's positive, and it's 64. So the next one is kind of a two-stepper. You've got to first kind of look at the 5 times the negative 3, get your products, your result, and then multiply that by a negative 2. So we're going to ignore the negative 2 for a second. So when a good thing happens to a bad person, that's a bad thing. So this would be negative 15. Negative 15 times negative 2, a negative times a negative, same sign, that would be positive. A bad thing happening to a bad person would be a good thing. And negative 15 times negative 2 would be positive 30. This is the tricky one, guys, and I need you to really listen. We're going to be talking more about exponents, but I just want to bring this up right now. What does this mean? So what number is being squared? What number is being raised to that second power? You are not multiplying. Your answer is not negative 8. It's telling you to take a number and multiply it by itself. In this case, what number? Well, the parentheses are telling you it's the negative 4 is being multiplied by itself. Negative 4 times negative 4. That's what that 2 means, that's raised up. So negative 4 times negative 4, a bad thing happened to a bad person would be a good thing. You have 2 of the same signs. This should have been positive 16. When a result is positive, you don't have to write the plus. You obviously have to write the negative. If you were to put the plus in front, though, I don't get fussy about that at this juncture. Okay, let's talk about division. Now, I'm going to be honest with you. The line with the little tots disappears in higher math, just like the x does. Remember that he's the leader. It's 36 divided by negative 6. So the first thing, let's look at the sign. We have a positive and a negative. Different signs. Your answer should be negative. And then what is 36? Divided by 6. What number times 6 gives you 36? And you should have gotten negative 6. Negative divided by negative, both the same sign, is going to be positive. A bad thing happening to a bad person is a good thing. And 30 divided by 5 is 6. Okay, now we're going to go over to actually the harder operations. Usually we think addition and subtraction of being easier, but with positive and negatives, they have to be thought about a little bit more. My story is gone, guys. When there's a plus or a minus, we're not going to be talking about good and bad people. It's only for multiplying and dividing. So in this picture, you're going to see sort of a reminder here. So to add integers, now integers are numbers that are not fractions, not decimals. We're going to start with the easy ones right now, and we're going to keep our fractions and decimals out. So if you are adding the sum, adding 2 numbers that have the same sign, the sign will stay the same. So basically what you're going to do is add the values and keep the sign. Now let's see what this word absolute value means. You might remember that I mentioned in an email home that you all walk through my absolute value machine every day. If you don't remember that, the next time you come in, look over the door. Absolute value means the positive. So when you take the absolute value of a number, it is always positive. And the reason we have something in math that gives you something that's always positive is because of distance. When you travel in your car, whether you go forward or you reverse, you're still covering distance. So when we're talking about the distance a number is from zero, it's always positive, and that's what absolute value is. So what you do when you're adding numbers that are positive or negative, you take the absolute value. So we kind of think of this as 34, and we think of this as 23. That's what I mean by absolute value. Look at the positives. If they are both negative, you add those absolute values, 34 plus 23, and then you keep the negative sign. So up here, they are both negative. You add the 7 and the 3, you add the absolute values, and you keep it negative. If they're both positive, you add the absolute values, which are positive, and you keep it positive. So when adding two signs that, numbers that have the same sign, you add their positives, their absolute values, and keep the sign. So this one would be a negative 57. If you're adding them with different signs, okay, you're going to subtract the absolute values and keep the sign of the bigger value. So let's take a look at this one. So for a minute, because they are opposite signs, we're not going to add. We have a positive and negative. We have one of each. So we're going to take the 8 and the 3 and take 8 minus 3 and get 5. Once we get that value, go back and look at your two numbers and ask yourself, which one was heavier? Which one had more weight? The positive 8 had more weight, so your answer is positive. Now over here, it's the same problem, except the negative is reversed. So we're still going to look at the positives, the absolute values. Take 8 minus 3, you're going to get 5. But this time, the negative 8 had more weight. It's negative, so your result is negative. So let's try this one. We're adding one of each. We're going to take the absolute value. We're going to look at 33, and this time we're subtracting 16. So 33 minus 16, that's going to be our answer. And is it positive or negative? Who is heavier? More weight to the negative 33, so your answer is negative, and it's negative 17. Okay, here comes your chance. So can you pause the video and do number 7 and 8, and when you have your answers, come back. The Edpuzzle may stop and have you answer it anyway. Okay, let's see how you did. Did you add 12 and 18 because they're both negative, both the same sign, and did you keep it negative? Now, a negative and a positive, one of each. Did you subtract 25 minus 15? And then because the 25 is heavier, is your answer positive? Should be 10. Okay, let's move on to our subtraction. And a lot of people look at these different ways. So you kind of can think about an idea of don't touch the leader and do a change. Some of you might remember same, change, change. I'm going to remind you of both. I'm going to use the example kind of up here. So 4 minus 7. So you don't touch the leader. He stays positive. But that single minus changes to plus a negative. So subtracting is the same thing as adding the negative. It's called the additive inverse here. Negative 7 is the additive inverse of 7. But 4 minus 7, a single minus becomes plus a negative. And when you do that, now we're back to our addition rules. And since it's one of each, 7 minus 4 gives you 3. And that is a negative. It's heavier, so it's a negative 3. The other way some kids learned it is with the word same, change, change. So you keep the 4 the same, positive. You change the minus to a plus, and you take the positive 7 and make him a negative 7. So same, keep the 4, change the minus to plus, change the positive 7 to negative 7, and then you use our addition rules. If you have the, what I call the double minus, the minus a negative, subtracting a negative actually becomes a plus. And here's how the same, change, change works. keep the 4 the same, change the minus to a plus, change the negative 12 to a positive 12, and then use your addition rules. So same, change, change. It's one of each. Subtract and keep the negative because the 12 is heavier. Same, change, change. They're both positive. Add them and keep the positive. Same, don't touch the leader. Change the minus to a plus. Change the negative 10 to a positive 10. It's one of each when you're adding. In our last slide, when you have one of each, you're going to subtract the value. So 10 minus 5. And since the 10 is heavier and positive, the answer is 5. Subtraction is the most difficult of the operations because you've got to do that change to addition first. So now it is your chance, to give these a try. Pause the video, answer the questions on the puzzle, come back when you're all set, and let's see how you did. Okay, so a single minus becomes plus and negative, or you can do the same change. It's one of each. 11 minus 5 is 6, and it should be negative because the 11 is negative. Negative 16, don't touch the leader. He stays the same. Same. Change the minus to a plus. Change the positive 10 to a negative 10, and now you're adding 2 that are the same. Add their positives and keep it negative, and the answer is negative 26. Here's the weird one, right? These are the two tough ones. When you have minus and negative, that's going to become a plus. Or the way to look at it is same, change, change. So the 12 stays the same. The minus changes to a plus. The negative 9 changes to a positive 9. And we know how to do that one. Just add them and keep them positive. Don't touch the leader. Keep the negative 8 the same. The leader never changes. Change the minus to a plus. Change the negative 15 to a positive 15. There is your same, change, change. Oh dear, it's one of each. When it's a positive and negative, we subtract and keep the sign of the heavier, and you should have gotten 7. Those are our basic 4 operations reviewed with integers, guys. Just to remind you, if you see a negative fraction, a lot of times people get all confused. Where should I put the negative? There's 3 ways to write a negative fraction. You can put that negative sign out in front, kind of in the middle, right, between the numerator and denominator. You can hook it to the numerator. You can hook it to the denominator. But a negative fraction never has a negative at the top and the bottom. Because if you have a negative divided by a negative, that would actually be a positive. So if you have a negative fraction, you basically put the negative in one of these 3 places, one negative. So let's bring our rational numbers in. Remember from our last discussion that rational numbers are numbers that can be written as a ratio, as a fraction. We talked about them being fractions, terminating decimals, and repeating decimals. We're just going to take a second here to remember how to multiply fractions. We're only going to do multiplying fractions today. So I just want you to see that the rules are still the same. We know we're multiplying because there's no addition and subtraction. The parentheses next to the parentheses mean multiplication. The next thing we know is we're going to be really happy because we can use Mrs. Woodruff's story. So we have a negative times a positive. A bad thing happening to a good person would be a bad thing. So we're going to start by having a negative. Whoops, right there. Okay. Now, the next thing, if you remember with multiplying fractions, there are basically 2 ways to do this. You can reduce, you can cross-cancel before you multiply, or you can multiply and then simplify. I'm going to do one of each. So what I notice is in the corners, 5 and 15, I'm not looking at the 2 and the 8. The 5 and the 15 are both divisible by 5. So this would become a 1, take out 1 5, right? And here, when you divide by 5, you would have 3 5s. Now going to the other corners, they're both even. I can divide by 2. So there's 1 2 here, and there are 4 2s here. So when you cross cancel, you might remember that it looks something like this. So divide 15 by 5, get 3, divide by 5 and get 1. 8 divided by 2 is 4, 2 divided by 2 is 1. And now you multiply the new numerators and the new denominators, and don't forget that it should be a negative, and we get negative 1/12. The other way to do it is to not look for cross-canceling and just multiply the numerators, multiply the denominators, and then look to reduce at the end. So here, first of all, a good thing happening to a bad person would be a bad thing. And I'm just going to multiply the 3 times the 2 and get 6, and the 5 times the 9 and get 45. Now with this way, you've got to look to see about your divisibility rules. They don't end in 0. They don't end in a 0 and a 5. They're not both even. So I'm wondering if they're divisible by 3. So 6 is divisible by 3. And remember, we add these. 4 plus 5, 9 is divisible by 3. We can divide both by 3. 6 divided by 3 would give you a 2. And 45 divided by 3 will give you 15. And don't forget it's negative. So just to show you and kind of give you a quick reminder of 7th grade multiplying rational numbers. It was the 2nd unit last year. So the final thing that we want to talk about today is, what is this variable thing? Okay, so it's substitution. When we see a letter in math, it's called a variable. We're going to be talking a lot about that again this year. And basically what I'm doing is I'm giving you rules for these 3 problems and telling you what numbers you're going to substitute in for the different variables. Now, when the 2 variables are next to each other with no sign in between, it's multiplication. So we're going to take whatever A is and multiply it by whatever B is. And the first thing you're going to do is show me that substitution. So the A became a negative 2 and the B became a 3. And now we're right back to Mrs. Woodruff's story here because it's multiplication. Bad thing happening to a good person would be a bad thing. And 2 times 3 is 6, so negative 6. What I want you to do right now is pause your video and just write the substitution. Let's start there. And when you're ready, play the video. Okay, let's see how you did. What did you put in and substitute for B and C? And notice when I substitute, I catch it in the parentheses. I call that catching that in the gloves. So the B became a 3 and the C became a negative 5. And I caught that in the parentheses because if I don't, it might look like subtraction. Remember that it's B times C. Okay, here come our order of operations. We're going to start back here, and 3 times negative 5 will give us a negative 15. So we're going to have 7 minus a negative 15. Now we're at our same change. We're going to keep the 7 the same, change the minus to a plus, change the negative 15 to a positive 15. Man, this is using a lot of our rules. Ooh, it's positive. Yay. And 7 plus 15 is 22. Positive plus a positive stays positive, and you add them. Okay, again, can you pause the video and simply start by substituting in what A, B, and C are? And if you substitute a negative number, catch it in the gloves, put it in the parentheses. Once you've written this problem down with all of the substitutions, play the video. Okay, let's check your substitution. So is this what you have? So A became negative 2, B became positive 3, minus, and C became a negative 5. Okay, what I would like you to do is simplify the denominator. What is 3 minus a negative 5? Can you please pause the video and come up with that? Okay, let's see how you did. Do you have negative 2 over 3 plus 5? Same, change. And 3 plus 5 is 8. And now before we finish here, this is, they're both even, so we can simplify it. Divide both by 2. And did you get negative 1/4? So guys, that is our review of positive and negative operations. When you come into class, we'll do some together. And we'll do a fun quiz. So make sure your Chromebook is charged. Guys, have a great day.